Right, friends. So, what exactly are microservices? In order to understand what microservices are, before that we must understand what exactly the monoliths are. And it's absolutely simple thing to understand what a monolith is, because we have been developing applications since ages which are monolith applications. And when you say monolith applications, these are the applications which are full blown enterprise applications with all the services. When I say all the services, these services may be accessed by the external systems. Maybe these services are soap based services, or maybe they are restful services, or maybe they are just simply large huge web applications, right? Maybe, so there was a time when we used to not work with an API based architecture, but we used to work with an architecture wherein, in fact, using something like GSF, Java Server Faces, we used to develop applications which had the entire user logic implementation also server side. So the execution of the user logic was happening server side, and it used to render the HTML to the browser. That's how it was. And then, yes, came in the time when we used to use jQuery very heavily, and we used to develop applications which were kind of more dynamic in nature when it comes to interacting with the user. When the user interacts with your system, it's not that the entire page gets refreshed. So then the concept of SPA came in, this the single paged applications. And then, yes, started working with the API based applications. But well, whatever the scenario is, today also you will find many software solutions which are architected such that all the APIs, all the RESTful APIs are designed in such a way that they sit on top of one single enterprise application, huge single enterprise application. So if you have to deploy such an application, so suppose this is what your large enterprise application is, and of course it would definitely be a modular approach, right? Needless to say, you will have a modular approach for sure, and you will be having n number of modules. In case of Java technology, you won't have those modules as jar files. So maybe you create one module for sales, another module takes care of all the services of purchase, yet another module takes care of all the services of customer management, yet another module which takes care of all the address management. All of these are different modules resulting into jar files. But then all of these modules are assembled and deployed as a monolith. So it's one single application that is deployed. So if that is the kind of architecture that you have, then in that case, okay, let me increase the font size out here. So 17 should be good. And suppose you've got that monolith application, I'll say M1, deployed on this machine. Now, of course, for such a monolith application to work well and to serve well, it would definitely needless to say, it will definitely require a good amount of hardware, right? I mean, when I say good amount, what I'm trying to say is that it will require a reasonable size of the hardware, the memory that must be made available on that box, and then the disk space, the memory space and stuff and all, and also the computing power of this entire server. Maybe that is a virtual server or server on Azure, maybe it's a virtual server on Amazon. You do get powerful servers with good amount of resources on the server, from which is still a virtual server, but then really very powerful server from all of these different IaaS, infrastructure as a service kind of platform. So maybe from Amazon you've got a server which is a full blown server, having good amount of computing power on it, because you will need it, right? You will need such a server to deploy a large monolith application. Now, of course, if not for any other reason, you will definitely have at least two servers in the cluster. Why will you have to, why would you need two machines in the cluster? Why? Because maybe if one goes down, if one crashes, then in that case at least the users will be able to get their request served from the other machine. So you will need, if not for any other reason, if not for scalability reason, at least for failover reason, yes, you will definitely have you have at least two instances in a cluster. So you have to incur the cost of having the similar kind of hardware, yet another box in the same infrastructure, maybe in a different region, but you will have yet another hardware procured. You will have to procure yet another hardware so that you can replicate that entire monolith on that another box, to support that failover. And of course, if you've got, instead of one machine, if you've got two machines, you will certainly have a load balancer, and this load balancer will be actually facing the client. So each and every client that sends a request, maybe a mobile application, maybe you've got a mobile application, or maybe okay, now let me bring this down. So maybe a mobile application, or maybe you've got a browser based application, or maybe any other third party application that wants to invoke your APIs. They will be sending the request where the request lands on the load balancer, and then in turn this load balancer, okay, so let me select this and I will say style, and then the size, it should be round shape. Okay, so from the load balancer, again the load balancers, you can have a hardware based load balancer, like for example F5, or maybe you have got a client based load balancer. There are n number of load balancing frameworks available. So whatever you use, that load balancer will forward the request to any one of these instances in the cluster. Now if you want to scale further, now see the scalability part of it. So if suppose this one single machine is capable of serving maybe 500 concurrent requests, and then this machine of course of the same size will also be serving 500 concurrent requests. So at any given point of time, any one of those requests gets forwarded to any one of these two instances based on either weight based algorithm, or maybe based on round robin algorithm, whatever it is. But then these two machines will take the load, right? And that's what you have. But then if you want to scale up further, right, and you have this one machine, yes of course, and then you have another machine here, but then you want to scale further and you want to now support maybe 1500 users, 2000 users on this application, then what do? You have no choice but to have yet another hardware procured, and you deploy exactly the same large monolith application on what, on this third box as well. And similarly you keep on scaling up, but this scaling is extremely expensive. It is pretty expensive. Why? Because of the cost of the hardware, and in terms of maintenance also. Whenever you decide to have a new version deployed, or if there is a minor bug fix, perhaps forget about a big release. If it's a big release, it's absolutely okay, that you have got to spend good amount of time and effort to take that new release into production. But then if it is a minor bug fix, or maybe if it's a small enhancement that you want to deploy, my dear friends, you will have to redeploy that entire application across the entire cluster. And I mean across the entire cluster, on each one of these instances you will have to redeploy that entire application, and that's not a joke. It takes good amount of time and effort both, right? And then you are tied up with the entire technology. So if your entire monolith application, all the services, customer management related services, order management related services, let's take an example of an Uber app, kind of an Uber app. In case of Uber app, you've got customer services, so customer management, everything with respect to adding a new customer, deleting a customer, updating a customer. Then you also have services with respect to the addresses of that customer. You save multiple addresses of that customer in the system. Then you have got the concept of booking a cab, which is very very extensively used. Then register as a driver, and then put some amount in the wallet. There are so many services. If all of those services are built into a single monolith application, my dear friends, and if you decide to build all of those services, that entire monolith application using PHP, then of course needless to say that's the one single monolith application. So on M2 also it's the same PHP based monolith application that you redeploy here, right? You replicate here, and then again the same monolith, absolutely the same monolith PHP based application is supposed to be replicated here on M3 as well, right? And all the other instances. So you are tied up here with the technology, because all of your services are built on top of one single monolith using a particular technology, right? That's how it is. So it's not really very convenient these days. There was a time when the changes that the stakeholders used to ask for in their existing applications, their software solutions, was not at that high rate. My stakeholder would ask for a change or enhancements, maybe 3 or 4 changes in a month, or maybe a big release in a quarter. But those days are gone. Today if you ask the stakeholders, the stakeholder comes up with an idea. Okay, there is a competitor, they are giving this feature, they have the service now. Now I also want to, we also want to provide the service in our system, in our solution. Suppose say you've got Swiggy and you've got Zomato. These are two different food restaurant aggregators, right? So if suppose the Zomato aggregator, they come up with a service, and then Swiggy says, okay, we're going to come up with a better service. Now they come to you, to you are the service provider, you are the team which manages the application, and if you ask them when do you want the service to be deployed, they will say yesterday. Right? They will not even say tomorrow, today, or tomorrow. They're going to say yesterday. It's going to be, I mean, it is supposed to be ASAP. So in such a case, you cannot really go ahead with this kind of an architecture wherein you deploy monoliths. All the services are built on top of that one single application, and that one single application serves I mean, hosts rather, I would say, all the services, all the endpoints. That doesn't really work very well. Okay, so what do you do in such a case? So what do you do? So this is that typical monolith architecture. But as opposed to this, what you can do is that I'll just keep this drawing as it is, and I'll start from here onwards. Now suppose so what are the kind of services, like in Uber app itself, we just talked about. You've got customer related services, you've got address related services, you've got booking a cab as yet another service. You can also, of course, not just book a cab, but also you can cancel a cab, and you can change the booking that you have done. Maybe you wanted to change the destination and so on. So there are so many services. Now what you do is that you decide based on the domain entity, based on, okay, there are various different factors based on which you decide what will become one service and what will become another service, and what in fact what a service is. So if you want to master the art of breaking down a monolith into a microservices based solution, then I would strongly recommend you must study domain driven design. I repeat, domain driven design. This is just simply superb. This is what you need to learn. You see, this domain driven design, you also have on Wikipedia, you can say DDD, and you will find some good a very good article on DDD. Okay, here you go. See, on Wikipedia you will find some building blocks out here. And what are the building blocks? You will find that the building blocks are like you've got the domain entity, you've got the bounded context, you have got entity, you've got value objects, you've got aggregates. So if you understand how to do domain driven design, it becomes easier for you to break down a monolith. You learn, you understand, you master the art of breaking down a monolith into microservices. But to give you in a nutshell, just to give you an overview, a microservice is not necessarily one single endpoint or one single RESTful API. One single microservice will be like it will be kind of a bounded context. When I say bounded context, the context of a domain entity, and there will be a boundary around it. Say for example, customer is one bounded context, invoicing is yet another bounded context, booking is yet another bounded context, right? So all of these are bounded contexts. Now you build your services in such a case, like for example, booking is one service, or say invoicing is yet another service, you say customer management is yet another service. So all the endpoints that you would want to provide with respect to managing the customer, creating, updating, deleting, activating, deactivating, all of these endpoints, all of these services, all of these RESTful APIs that you would want to provide, you will be providing in one single app. Note my words, I'm saying you will be providing that in one single app called customer management service. So I'll say customer management is one service. So as I said, please do not be under the impression that this is one single RESTful API. No. This is one single app, an application. Now note my words, this can very well be developed in Java using Spring Boot perhaps as the framework, or maybe using PHP, or maybe you build the service using .NET, or maybe you build the service using JRuby or whatever, or maybe Node.js based application, right? These are the two most extensively used. Node.js based applications, you've got Java based Spring Boot based application, or maybe you've got a PHP based application. So this is one service. It may have n number of endpoints. So creating a customer, updating a customer, deleting the customer, getting the list of customer, finding a customer based on the ID, getting the customer based on a city. Give me the list of all the customers that comes from city Mumbai. So all of these kind of endpoints will be implemented here in this one customer management service, one Spring Boot based application, which will result into one single .jar file. Got that? And then you will have another service, I'll call it yet another service, or maybe that is invoicing. right? That will be invoicing. So invoicing is yet another service altogether, creating a new invoice, canceling the invoice, or maybe getting the list of all the invoices and finding an invoice, searching an invoice, all of those invoicing related services, making the PDF of the invoice available to the end customer. All of those invoice related endpoints will be implemented here in invoicing application. When I say application, it's not a full blown enterprise solution. It's an application just enough and just good to serve one particular bounded context, one particular domain specific concept, which is invoicing. So this invoice is a domain entity, it's a domain class, right? Customer is a domain class, it's a domain entity, right? And you've got a bounded context out here. All of those services, all of those operations, the business operations that are supposed to be provided within that bounded context will be all implemented in that one single service. You got that? When I call it as a microservice, when I say a microservice, it's just an app, and it's not something which will have all the services of an enterprise solution implemented in it. You will have only and only those RESTful APIs, right? Those endpoints implemented here in customer management, which takes care of the business operations of only and only customer management. Similarly, you will have invoicing. Similarly, you may have, in case of Uber app, right, bookings. Okay, so creating a booking, canceling a booking, updating the destination or changing the pickup point, whatever, all of those booking related business operations, those activities will be all implemented in the booking service, right? And they are deployed, all of these services are deployed on the infrastructure in such a way that this customer management will be running in its own Docker container. So where is this customer management service deployed? It's deployed in a Docker container. So instead, let me do something like this. I'll draw, suppose this is that Docker container in which that service is running, right? This is that Docker container, right? So what is this? This is my Docker container. Say Docker container 1, Docker container maybe 1. Okay, that's how it is. So this is my Docker container in which that customer management service is running. I will have another, okay, let me group this up. I will have yet another service which is invoicing, which will again be running in its own Docker container. When I say a Docker container, this Docker container is actually nothing but a machine. Again, it's a virtual machine. This Docker is a technology which is built again on top of hypervisor technology, right? And this is a machine, a kind of a virtual machine. So here you say I have got a Docker container 2, right? And it is this Docker container in which my invoicing service is running. So instead of running the entire large enterprise monolith enterprise application running on one box, you have got services, all customer related, customer management related services, the endpoints, I would say, rather. So I will call it customer management service. This is one microservice, and having several endpoints, all the business operations that are represented by those respective endpoints will be implemented here in this customer management service, right? And that is running in its own Docker container on a different machine, right? This invoice is running in yet another Docker container, and this is running in its own machine, in its own environment. And these Docker containers, as I said, are virtual machines, and they have, of course, if it's a machine, there is an operating system supporting that virtual machine. So that operating system is again not a full blown operating system. I repeat, it's not a full blown operating system. It's the operating system that is just good enough, with the services just good enough to, right, I'm sorry for that. Okay, so this is an operating system which is just good enough for you to host that particular service. So this Docker container out here is simply good enough to host customer management service, which is running in a Spring Boot kind of an app. It's a Java application. For the operating system, it's nothing but a Java process, whether Spring Boot framework or whatever, that doesn't really matter. So you've got a service running out here, and it takes some 10 15 at the most API implementations, right? 10 15 API implementations. So at the most, that's what I'm saying. I mean, it's not that there is a cap or something out here for a particular microservice. You cannot have more than 15 endpoints implemented on it. No, that's not the cap or something. But then usually that's how it is. Like, 8 10 maybe 10 15 kind of RESTful APIs implemented in one single service. So what will it need? Maybe 300 400 500 MB of RAM. That's exactly, at the most, that's what it would need. So you will have that customer management service running in a Docker container, which is just good enough. That's a virtual machine with an operating system that is just good enough to host that 500 MB of app. Similar is the case with invoicing, similar will be the case with booking, and so on. Each one of these services, microservices, having their own respective, having the implementation of their own respective APIs, will be all running in their individual Docker containers. What's the benefit? Why? Why, instead of deploying all these services as one single monolith on one single machine, why are you distributing your services across multiple machines? So that, see, for example, here, the best example is the Uber app itself. Now tell me something, here, what do you think? Don't you think that something like, in an Uber app itself, right, in the same example. Okay, let me first complete this, send this to back, and then I've got my booking service out here, and then I would say this is my Docker container 3. Okay, and I will group this up. Okay, right, so this booking, right, this is running. Now you're happy with this, but then you are a company wherein, you are now, okay, Uber is anyway, it's huge, it's mammoth, but if suppose you are coming up with your own ride sharing app, and if that is also catching momentum in the market, and if it's really doing very well, you would say, oh, I want to scale up. Now, as of now, you see that, okay, I am seeing that there are, 100 concurrent bookings happening at any given point of time, but I want to support, 1,000 concurrent bookings. Correct. So if it was a monolith application, and if all of these services were all built into one single monolith application, my dear friends, you will have no choice but to have yet another full-blown hardware with a full-blown operating system and replicate that entire application here on that new hardware. But if it is for this, don't you think you will be able to scale only and only on that one particular service? So you will have yet another Docker container. All right, you will have yet another Docker container hosting the same booking service. You will have yet another Docker container. So perhaps you've got 3 containers in which you are running the same booking service. Maybe if you scale so very well, and your business also scales so very well, and that results into the scaling demand on your enterprise application as well, you may down the line end up running 50 Docker containers or maybe more running the same booking service, whereas you do not have to incur the cost of, say, customer management and invoicing. That's not really, having so much of demand. Customer management, maybe yes, you have 2 or 3 more Docker containers. Okay, something like register as a driver, right? On an Uber app, one can very well register as a service provider. So in that case, that is not something which is very, very extensively used throughout the day. Maybe in a day there are maybe, 10 15 or 100 people trying to register as a driver, or sending a request to get, registered as a service provider. So maybe I call it driver management. Okay, so something like this, you don't want to scale on this, so you don't incur the cost on scaling on the entire, I mean, you don't scale the entire monolith application. You scale only on the services that has got the scalable, the demand. All right, so this is called, vertical scaling. I repeat, this is what scaling on y-axis is. This is what vertical scaling is, and this is extremely cost effective. Why? Because you don't have to spend, a fortune on having, a full-blown servers in the cluster. But these Docker containers are very easy to spin. They are tremendously fast. They are very, very efficient. And over and above that, you have got you've got orchestration tools like Kubernetes. You've got Docker Swarm. You've got OpenShift. You've got Heroku. You've got so many PaaS, platform as a service out there that provides the entire containerization based infrastructure, wherein you can just simply, in fact, you can configure in your developer, and it is that I want to auto scale. If suppose this is what the parameters are, based on which automatically the number of containers must be automatically spent. Maybe you scale up, so during 9 o'clock in the morning to 12 o'clock in the afternoon, you know that there is a surge in the bookings, and there are you've got a huge number of requests coming to your application. And in that case, you will say, oh, okay, from 9 o'clock to 12 o'clock I want maybe 100 containers running bookings. And but during the during night time, after 10 o'clock, from 10 o'clock to morning 4 o'clock, I want just simply 10 containers running booking. In such a case, you will end up incurring the cost in night. At night, you will end up incurring the cost of only and only those 10 containers. Why? Because that platform as a service will charge you only and only based on the total number of containers that you are running at a given point in time. It's extremely cost effective. Over and above that, friends, see the second point, interesting and very important point here, is that I may have developed a booking service maybe in Spring Boot, whereas I may have developed this invoicing service in Scala for some good reason. I may have developed this customer management in maybe PHP, and this driver management maybe with a Node.js based application, even though there may be a need from invoicing to interact with the customer management service. Maybe there is a need. Okay, maybe there is a need, right? Maybe from invoicing you want to make a call to some service call needs to be made on customer management, maybe getting the list of all the customers, maybe getting a particular customer and its details. Maybe you need that. In such a case, there will be an HTTP call. What kind of call you will be making from here? It will be an HTTP call. Correct. So it doesn't really matter whether this was implemented in Spring Boot, or it was implemented in .NET or PHP or Node.js. It does not really matter at all, because after all, if at all one service needs to interact with the other service, the call is going to go through HTTP protocol itself, right? So you are totally independent of the technologies. Like you are not tied up with a particular technology. You can very well decide to build a particular service in whatever platform or a framework that you want. Over and above that, one last but not the least, of course, you have ease of deployment. Suppose you wanted to roll out yet another feature, for while the users are doing the booking. Maybe you wanted to add a new feature while they are doing a booking, or maybe you wanted to add a new feature as far as driver management is concerned in driver management service. Do you think you will have to redeploy all the other services as well? No, you will have to redeploy only and only this particular service, right, which is kind of driver management service. So all the other services are still running. You neither have to bring them down, nor do you have to restart them or anything. It is only and only this service that will be redeployed, as opposed to the monolith architecture, wherein you will end up redeploying the entire monolithic class across the entire cluster. Now here also, of course, there will be load balancing, and there will be there are loads of things that are required, because see, any new architectural style will bring its own set of challenges. I repeat, any architectural approach that you want to take, it will have its own set of challenges, and solution to those challenges are known as architectural patterns. I repeat, solution to those challenges are known as architectural patterns. Here, for example, there will be a challenge: how will one single service call another service with by what? By HTTP :/ what, some IP address colon some port number? Doesn't make sense, because the container that is running this may stop, may get started. Maybe there are now I have one container, maybe 10 minutes down the line I may have 3 containers running of customer management. So you cannot refer to it by IP addresses, of course. So then what would be the URL? How will you refer to the service? How will you invoke the service? And then so there is something called service discovery. I repeat, there are libraries available called service discovery. Using service discovery, Eureka, from Netflix OS as the implementation, and that helps you to register each one of the service by a particular name, right? I'm just giving you an overview. I don't want to get deep into it, but then you have other challenges with respect to the API gateway. You have API gateway here. So you have this one service, you've got another service, you've got yet another service. How will you reach to these services from your Angular app? Of course, you cannot keep on giving different domain names. Does not really make sense. You cannot refer to the IP addresses again from there. So you will need dynamic routing. from some kind of an API gateway. So Zool is again available from Netflix OSS. There are various different implementations available. There are various different solutions available to these kind of architectural challenges. We call them as architectural patterns. So the API gateway is the pattern. Service discovery is yet another pattern, and then having the common configuration somewhere, instead of having configuration into each one of these apps, you have some common configuration. So that's also is something that you would really need. A solution for that will be needed. Various other things, and then very important, stateless. Now this is supposed to be stateless. Again, here the scalability is very very high because this entire architecture is stateless. When I say stateless, each and every request that lands on a particular app over here, that may be from some of the other logged in user, right? So how do you identify the user out here? You do not identify user based on the user saved in the HTTP session. I repeat, that's not what the approach is, or is supposed to be. Not at all. You never store user objects in HTTP session these days. Absolutely, that's the old school. These are gone. You have an Angular app or a React app, or maybe a Vue based app, or maybe an Ionic based app running in your app, on your mobile, or maybe Flutter based app. Whatever these applications are, they each point of time, whenever they make an API call, in the header of the request they definitely send a token, and that token is actually provided by the authorization server. All in all, in short, it's not just simply the matter of distributing your services across different Docker containers or different machines. It's more than that. You need to have the solution for each one of those architectural challenges, better known as architectural patterns. And there are various different, the best among them, and the one that we use, not that the best or bad or something like that, here I don't intend to rate anything, but then the one that we've been using is the Spring Cloud. That's what we use extensively, right? So you've got Spring Cloud, and you can see here Spring Cloud. This provides you with a solution of all such architectural patterns, and this is what it is. So Spring Cloud, again, what, it's not that it's a different framework, but it's all the set of libraries that helps you to build a distributed application on top of Spring Boot. I repeat, these are set of libraries that helps you to build applications which are distributed applications, microservices based applications, sitting on top of Spring Boot. Right, that's how it is. So yeah, so this was an overview of microservices. If so that's how it is. That's all about it, right?